Hello, welcome back to the lecture series on network layer protocols of the internet model. In this video, we are going to learn about intra-domain routing protocols part 2. So what is the agenda? We will look into some of the examples of intra-domain routing protocols. Routing information protocol or RIP, which is based on distance vector routing, will be discussed here in the beginning. After that, open shortest path first or OSPF, which is based on link state routing, will be discussed next. Now, the examples of inter-domain routing are routing information protocol or RIP, which is based on distance vector routing, and it is a very simple routing protocol. And if let's say there are two autonomous systems, and in order to transfer messages between the nodes of a network having the routers and other networks, it is known as intra-domain routing. And the simplest form of interdomain routing is RIP, and this is based on distance vector routing, which we have already learned in the previous video. This distance vector routing is basically based on minimum path. Open shortest path first or OSPF is another intradomain routing protocol which is based on link state routing, which we have also learned in a previous video. This link state routing protocol basically depends on the knowledge of the links that the nodes have with respect to all other nodes to which these nodes are connected. Let us first concentrate on RIP. So this is an autonomous system having several routers and networks. Like here we have routers R1, R2 and R3, and the networks N1, N2, N3, N5 and N4 are within this autonomous system. So the autonomous system will basically have these nodes. Nodes are known as the routers, and we have the links, which are basically the networks. Routing tables are there in the router, which consists of the to field and the cost field and the next node field, whereas the networks do not have the routing tables. The destination field is basically the network field, and the first column of the routing table, which we have already learned in a previous video, will define the network address. The distance is defined by the number of links or number of hops. So hop count here is very much important. So if we have to create the minimum distance, so we consider the hop count. The minimum hop count will create the minimum distance. Now we have seen previously in distance vector routing there is a problem of instability. We have looked into 2-node as well as 3-node instability, and we have seen how the hop count becomes infinite after a certain period of time due to this instability. So infinity is defined here as 16. So this RIP system cannot have more than 15 hops. After 15 hops, if the system does not become stable, then it goes to infinity. The next column of the routing table defines the router address of the destination. So here let us look at this diagram. It consists of routers R1, R2, R3 and R4, and there are several networks connected to these routers. We are concentrated on finding out the routing table for R2. If we can find it out for R2, we can find out for all other routers also. So as before, the destination field is the network field. Network address, it gives the network address. The hop is the number of links, and the next field is the immediate next link. So here, let's say we want to go from router R2 to this destination 130.10.0.0. So 130.10.0.0 is here, and the router R2 can go to this network by one hop, and there is no next field because router R2 is directly connected to this network. Next, we go to 130.11.0.0. So this is here, this network. So if the router wants to go to this network, it has to go via two links. So there are two different links, and the next hop will be through router R1, and the link address will be 130.10.0.2. In order to go to this destination 195.2.4.0, this one, so it can go via single link. In order to go to 195.2.5.0, so here we have this network. Again, router R2 is directly connected to this. So we have a hop count of 1, and the next node field is blank. 195.2.6.0 is here, and the router R2 can go to this network via two links, and the next link address will be 195.2.5.2 because this is the interface through which it can move. In order to go to 205.5.5.0, which is here, so it requires three different links, and the next node will be 130.10.0.2. In order to go to 205.5.6.0, it can again go via three links, and the next link will be 130.10.0.2. Now we turn our attention to OSPF, or Open Shortest Path first. This is based on link state routing. Here, the entire domain is divided into several areas, and the metric that we used will be cost, which is basically based on the services. For example, it can be minimum delay or maximum delay, or the throughput, or any other service that the organization thinks suitable. There are several types of links also in OSPF, which we are going to study. So let us understand how the areas are created. In a domain, this is one area having networks and the routers, and there should be a border router at the boundary of area. So this is area 1. Similarly, we can have another area 2 having different networks and the routers. There should again be an area border router at the boundary of this area. Next, there should be another area 0, which is known as the backbone. Now this backbone should be connected to all other areas. Now we have the backbone router here. Backbone router is again connected to different networks. We can have several backbone routers in an area which is concerned as backbone. All other areas must be connected to the backbone area through this backbone router. It is the backbone router which takes care of the entire communication in the domain. So this is known as the primary router, and this area or the area border routers are known as the secondary routers. So this is the total autonomous system, and we have the autonomous system boundary router here, through which it is connected to all other autonomous systems. So this is the total autonomous system or intradomain routing that is happening with the help of OSPF. There are various types of links that is possible in OSPF. We can have point-to-point link, we can have transient link, we can have stub link, or we can have virtual link. This is an example of point-to-point link where two routers are connected to each other and not to any other router. And the example is the telephone links, which are also known as the T-links. This is an example of a stub network or stub link where a single router is connected to a network. So this stub network can either be a source or a sink For virtual types of links, if all other links are broken or disconnected, then the administrator is responsible for creating this virtual link between nodes of the network, and it may consider a longer path link to the nodes of the network. This is an example of transient network where all the routers are connected to a common line. So all the routers, they can send information via this common line or the link. This is an example of Ethernet. This is a transient network, but this is unrealistic in nature and not efficient. Why this is unrealistic? Because we can see here that all the routers are connected to all other routers. Here, let us look at this router. C is directly connected to E, and C can be indirectly connected to E via node D. So this is very much unrealistic, and it is not also efficient because the router will be confused as to which way to route the data. Rather, this is a realistic transient network where we have a designated router in between. It forms a star type of network, and all other networks can be connected to it. Let us look at the autonomous system and its representation. So this is the representation of an autonomous system. We have the networks N1, N2, N3, N4 and N5, and there are several routers here which are interconnected. Now we can see here that router A is connected to router D, and this is a point-to-point link. Similarly, router B is connected to router E, which is also a point-to-point link. Then we have this router F connected to a stub network. Router D is also connected to stub network. Router E also connected to stub network. Now, let us look at the graphical representation of the previous topology. Here, the networks are defined by a circle and routers are defined by a square. So here we can see here that network N2, N4 and N5 are the stub networks, and N3 and N2 are transient type of networks. To summarize, in this video, we have learned about several examples of intra-domain routing protocols. We have looked into the routing information protocol or RIP, which is based on the distance vector routing. And we have looked into OSPF or open shortest path first, which is based on link state routing. Thank you.